This is the video for Mod 7, Lesson 3B, Perpendicular Bisectors. The goals of this lesson are going to be to identify and apply properties of perpendicular bisectors and also apply properties of the angle bisector theorem. For the first definition we're going to look at is the definition of a perpendicular bisector. So this is going to be a line, a segment, or ray that bisects a segment, but also intersects to form a right angle. So it kind of two things going on here. So for example, if BD, which is this line right here, is the perpendicular bisector of AC, what that means is actually two things. One, it's perpendicular, so it intersects to form a right angle, but also it's bisecting or dividing the segment in half. So we actually can conclude two different things here. We can say that we know AB is congruent or equal to BC because it cut that segment in half, but also angle DBA is a right angle. So it actually tells us two different things. If we have a perpendicular bisector, we can use the perpendicular bisector theorem. So what that means is if we have our perpendicular bisector, and in this case, it was DB. For this example here, it's FH or HF. If that's a perpendicular bisector, and we know that these are equal, this is a right angle. What that means is any point that's actually on that bisector, so for example, point F is on that bisector. Since point F is on that bisector, we can actually say that the F is the same distance from E as it is from G. So essentially what that means is it creates a pair of congruent segments with that bisector. So the segments formed with the perpendicular bisector end up being congruent. So you get these congruent pairs. So but they don't necessarily aren't the same as, EH and EF aren't the same, but I do know that these new segments are equal. So EF is the same measurement as FG. The first example is actually using that perpendicular bisector theorem. So what we can see here is we have KB is perpendicular with HN, but it's also bisecting it, right? So these are a perpendicular bisector. It's a perpendicular bisector. So what that means is since K is actually on that bisector, that these two segments formed, so 3x and x plus 10, are going to be the same measurement or congruent. So since those are equal, I can set their expressions equal. We can solve for x, and the question is asking for what is the length of Kn. Kn is x plus 10, so I'm going to substitute that 5 in, and we get 15. So Kn is equal to 15. The next theorem we're going to look at is the angle bisector theorem. So it's kind of a similar concept. We're talking about perpendicular. So if a point is a bisector, is on a bisector of an angle, then it's equidistant from the two sides, and it should say of the angle, not triangle. So same thing for the converse. If the point is equidistant from the two sides of the angle, then it is on the angle bisector. So what that means is if I know that AC is an angle bisector, a few things we kind of know. We know that these two angles are the same measurement. What this theorem says is since point C is on that bisector, it's the same distance from both sides. And we measure that distance with a perpendicular segment, right? So it's not slanted or anything like that. And so that actually means that the segments I drew that we had here, BC, would have to be the same measurement as DC. So the distance from the two sides is the same, so those two segments will be the same length. For example 1, you can see that they are finding UI, and we actually have that these are both 19 degrees. So what that means is, since these are the same measurement, RU is actually a bisector, which means that we can assume that we have these two lengths that are the same. So these are 2x plus 5 is the same as 7x. So if we go ahead and set those equal, we can solve what we're trying to find. So we're going to solve it. We're going to get our value for x to be 1. And the question is asking for what is the measure of UI. So if I substitute it in, 7 times 5 is 35. And so UI would be 35. For the second one, same idea. This is actually the converse. So they give us that we have these right angles. Two segments are the same measurement. So that actually means that YM is a bisector. So I'm going to go ahead and set these equal because they represent the same measurement. And we're going to go ahead and solve. And so we're going to get our x value to be 3. And then the question is asking for what is YWM. So YWM, if I trace it out from YWM, is actually this 2x plus 5. So I'm going to substitute in the 3. And then we'll get this to be 11. So the measure of YWM is 11. Or WYM is 11. If you have questions, make sure you are trying the U-Try problems and then asking for help during class, signing up for T-Bolt time, or getting help in the center.